Okay, in section 3, we're still going to talk system of equations, but just how can we apply them to different real-life situations, and how can we create equations based off a situation, then solve it with the skills we know from section 1 and 2. So the statement above, if you read along with me right here, says many situations can be modeled and solved using a system of equations. The benefit to a system of equations versus a single equation is that you can solve for two quantities at once instead of just one. One of the best ways to get into this is just start looking at examples, get used to practicing these, and the more you practice, the better you get. I know sometimes different word problems can get a little difficult, so I'm going to try to break this down as well as I can and explain exactly what I'm doing for each one of these. So for the first example, twice a number minus a second number is -1. Twice the second number added to 3 times the first number is 9. Find the numbers. So let's identify that we have two different variables here. We have an x we can call. Let's just say that's the first number. We also have a y variable, and we'll say that's whatever the second number is. So we've labeled our x and y's. We don't know those variables, so we're going to call them x and y. Let's create equations. So equation 1 is going to come from sentence 1, right here. Twice a number, I could say that's 2 times that first value, minus the second number, we said was y, equals -1. Our second equation is going to come from the second sentence here. Twice the second number, 2 times y, added to 3 times the first number, 3 times x, is 9. Hopefully we're pretty good at solving these. I could do substitution, but that would be a little difficult to get one of these variables by itself. I think it's going to be quicker to do elimination. Now remember, step 1 in elimination is to put these in standard form. So I'm going to rewrite this. The first equation is already in standard form. 2x minus y equals -1. The second one, the x and the y need flipped, so let's rewrite it as 3x plus 2y equals 9. From here, I'm probably going to want to eliminate the y's. So let's multiply this first equation by 2, so that we'll have -2y on top and then +2y on the bottom. So when I do that, let me rewrite what I have. 4x minus 2y equals -2. 3x plus 2y equals 9. And then with elimination, remember we add these. 4x plus 3x is 7x. These two eliminate. -2 plus 9 is 7. Divide both sides by 7. You get x equals 1. So our first number is 1. Now we need to find the second number. Let's plug it back into one of the original equations we came up with. I'll probably use the first one here. There's less coefficients. So let me plug 1 into that equation. And then solve for y. So 2 times 1 is 2. I'll subtract 2 from both sides. Divide by -1 to get +y is 3. So that means if we answer a question here, one number is 1, the other is 3. And there we go. Okay, next question. Jim needs 320 feet of fence to enclose a rectangular lot. The length of the lot is 40 more feet than the width. What are the dimensions of the lot? So if we need to enclose a rectangular fence, if I just draw a fence up here as a picture to get us started, I know I have length and I have width. So let me label those. Length up top, width on the bottom. To get the completely enclosed outside, that would be like finding the perimeter, where we need to do the width plus the length plus another width plus another length. So when you see these perimeter questions, our first equation is going to come from taking 2 of the lengths plus 2 of the widths and setting it equal to the total perimeter of 320. Again, L is my length and W is my width. So that's my first equation. The next one comes from the second sentence. The length of the lot is 40 more feet than the width. That means I have a length, and I can set that equal to whatever the width is plus an additional 40, because the width plus 40 is the same distance as the length. From here, to solve this, it looks pretty easy to set up as substitution, because L is already solved for in this equation. So let me take what L equals, substitute it in, get 2 times W plus 40 plus 2W equals 320. I can distribute the 2W plus 80 plus 2W equals 320. Combine like terms. 4W plus 80 equals 320. Subtract 80. Let me bring that up here. 4W equals 240. Divide by 4. W equals 60. So the width is 60. Let's go back to one of our original equations. It looks like, again, the second one, the second red equation, is definitely going to be easiest to plug in for W, because all I have to do is take 60 plus 40, and my length is 100. So we have a 60 by 100 area to fence in. 60 by 100 to fence in. Okay, the next question is more of a geometry-related question. So it says, find the measure of 2 supplementary angles such that the measure of the larger angle is 32 degrees greater than the measure of the smaller angle. To do this, we need to know, first off, what supplementary means. Remember, supplementary angles add to 180 degrees. They add to 180. So we know we have 2 angles here. Let me label those. I have S is my small angle, and then I have L is a large angle. So S and L. The first bit I'm going to get from the first part of the sentence. Find the measure of 2 supplementary angles. If supplementary means those 2 angles add to 180, I can just put that in my statement. The small angle plus the large angle equals 180. My 8s are pretty poor. Let me try that one again. There we go. There's my first equation. The second equation comes from the second part of the sentence. The larger angle is 32 degrees greater than the measure of the smaller angle. That means the large angle is going to equal the small angle if we add 32 degrees to that small angle. From here, it looks like substitution again. So let me take that large angle L, substitute that value in, S plus 32 equals 180. Nothing to distribute, so I can just combine like terms. 2S plus 32 equals 180. Subtract 32. Let me finish that up here. 2S equals 148. Divide by 2. S equals 74. So our small angle is 74 degrees. The large angle, well, I'm going to plug it into the second equation because that seems easiest to solve. 74 plus 32, and that gives me a value of 106, and that's in degrees, right, for the large angle. Let me put a degree sign on the small one as well. Okay, let's look at some more examples, in this case, of rate problems. So we have a question here where two trains leave Tulsa. One goes north, one goes south. After 4 hours, they're 376 miles apart. If one train is traveling 10 miles an hour faster than the other, what is the speed of both trains? So first, let's do some variables. We can say X is train speed 1, because we want to know the speed of the train. Y is the train speed of the second train. So train speed of, we'll just say first, train speed of the second, just to keep things organized. So I think our first equation is going to come from the first sentence, like usual. After 4 hours, they are 376 miles apart. Well, because we're going to measure this in miles per hour, it looks like, we can say after 4 hours, the train speed of X plus after 4 hours, the train speed of Y equals 376 miles. Our second equation comes here. One train is 10 miles an hour faster than the other. So let's say train 1 is the same speed as train 2 if you add 10 miles per hour to it. Again, this one looks nice to substitute for X, so let me do that. 4 times Y plus 10 plus 4Y equals 376. And then I'll do my algebra, distribute the 4 first. Combine like terms. I'm also going to subtract this 40 over in the same step to save a little room. So I have 8 y's when I combine 4y and 4y equals, will those cancel, 336. If I divide both by 8, I get y equals 42. And remember, that's the train speed in miles per hour. 42 miles per hour. Well, let's take 42 and plug that back in, probably into the second equation again. It looks easiest. Well, 42 and 10 gives me that the other train is going 52 miles per hour. Okay, for this next example, we have a group of neighbors went to a play. There were 10 more adults than children, with a total paid admission of $620. If the adults paid $12 and the children paid $8, how many adults and children went to play? So defining our variables first, we can say, let's just use A for adult, the number of adults. C for the number of children that go to this play. And let's create our first equation based off the number of people. So it looks like this first, or I guess the second sentence in this says there were 10 more adults than children that went to this play. So I could say adults equals the children plus 10. The second sentence, if you ever see a cost, that's going to be one of your equations. So we know that $12 for adults, we're going to represent that with multiplication. $8 for children equals a total amount of $6.20. So we have the number of people equation and the cost equation. This one's setting up nicely for substitution again. Substitute that in for A. 12 times C plus 10 plus 8 times C equals 620. Let's distribute. Combine the C's. I'm going to subtract 120 from both sides. 20C equals 500. And then from there, divide by 20. And you get C is 25. So there are 25 children that went to this play. From there, I'm going to choose the first equation that we created to substitute in A equals 25 plus 10. There are 35 adults. Okay, another money question here. We have a fourth grade class contributed $17.70 in dimes and quarters to the Red Cross. In all, there were 96 coins. Find the number of dimes and quarters that the children contributed to the Red Cross. So in this question, we have our variables are the number of dimes and the number of quarters. Our first equation has something to do with cost. Now I know a dime cost me 10 cents. So I'm going to represent that as a decimal. 0.10 of a dollar, so 10 cents, times dimes, plus quarters are 25 cents times the number of quarters, gives me a total of $17.70. The next equation is going to come from the number of coins. So the number of dimes there are plus the number of quarters gives me 96 different coins. So this one really sets up for elimination or substitution. Doesn't really matter. I might do elimination because it's been a while on this assignment. We haven't really done much elimination. Let's eliminate the Q's. So looking at this top equation, I'm going to multiply this by -4 to eliminate the Q's. So rewriting the top equation off to the side here, I'll have -0.40 dimes plus -1 Q equals -70.80. I'm going to copy down the second one the same. We can see the Q's are going to eliminate when we add. So I have 0.60 D, Q's eliminate, and then 25.2 divide by 0.60, and then the number of dimes is 42. There are 42 dimes. Let's definitely substitute that in the second equation. 42 plus Q equals 96. Subtract 42 So the number of quarters is 54. So just to kind of sum up this section a little bit, the challenging part is definitely creating the equations based off the word problems. So use this for the different types of word problems you can get on your assignment. Keep these notes handy, and make sure to ask me for any questions on setting up equations as you work through the assignment if you need them.